Alright, let's go. Number 10. The Hills Cloud. In the 1980s, astronomer Jack Hills was trying to explain a boring bookkeeping problem: why long-period comets kept arriving from roughly the same distance, again and again, instead of a smooth random spread. The standard model held that the Oort Cloud was one diffuse shell of icy bodies, thinning out gradually to nothing past 50,000 astronomical units. Hills ran the numbers and found the outer Oort Cloud couldn't have survived 4.5 billion years of passing stars without being stripped bare. There had to be something denser, closer, protecting it. Hills published his result in 1981 in the Astronomical Journal, calculating that an inner shell, now called the Hills Cloud, could contain up to 20 times more mass than the outer cloud, quietly parked between 2,000 and 20,000 astronomical units. Astronomers proposed it was a relic disk left over from planet formation. Failed. The modeled inclinations don't match what a simple leftover disk would produce. They proposed it was outer Oort material pulled inward by one passing star early in solar system history. Failed. The density profile is too smooth and too uniform to trace back to a single gravitational event. They proposed the whole structure was a mathematical convenience, a patch invented to make the numbers behave. That one hasn't failed exactly, it just hasn't been ruled out, because nobody can test it. 45 years later, the Hills Cloud remains entirely unobserved. Not one object confirmed, not one image, not one direct detection of any kind, despite decades of instruments built specifically to look. We have built a mathematically necessary structure, presumed to hold up to 20 times more mass than the outer Oort Cloud combined, and we have never seen a single piece of it. Every long-period comet that will ever fall toward Earth is, statistically, already sitting out there right now, waiting on a shelf we cannot see and have never photographed. What is actually sitting on that shelf? Nobody has ever seen it, but it may already be moving. Number 9. The unidentified dimming objects. In 2016, astronomers running the wide-field Zwicky Transient Facility and its predecessor surveys were simply cataloging stars, building a baseline brightness map of the sky to hunt for supernovae and asteroids. The standard model predicts every dimming event should trace back to something known: an asteroid crossing the line of sight, a binary star eclipsing itself, a planet transiting its sun. Instead, survey teams kept logging brief, sharp occultation-like dips with no corresponding object ever recovered in the data. Kevin Shawinski and Chris Lintott's Citizen Science Network flagged dozens of these transient dimming events between 2016 and 2021, published in follow-up notes through the Zooniverse platform, each one lasting seconds to minutes with zero matching catalog body. Astronomers proposed instrument glitches, dead pixels, or cosmic ray hits mimicking real signals. Failed. The dips show real physical light curves that behave exactly like something passing in front of a star, not sensor noise. They proposed uncatalogued small asteroids drifting through the field. Failed for a meaningful fraction of cases. The geometry required implies objects on the wrong side of the sky entirely, or moving at speeds too fast to be gravitationally bound to the sun at all. They proposed cometary debris, loose material shed from a known body. Failed for most cases: no dust signature, no tail, no coma, nothing trailing behind. They proposed binary star systems misidentified as single stars, ruled out for the clearest examples, where the target star had already been resolved and confirmed single. Something with real physical mass keeps crossing our line of sight to distant stars, and then vanishing from every follow-up image taken minutes later, leaving no trace behind for any telescope to recover. If even 1% of these events are solid, unbound bodies, our count of what shares the inner solar system with us is off by an unknown, possibly enormous factor. What exactly keeps blinking out the stars? The list of unexplained dips keeps growing every observing season. Number 8. The Kuiper Cliff. In the late 1990s, Gerard Kuiper's namesake astronomers were mapping the population of icy bodies beyond Neptune, expecting the belt to thin out gradually, the way stellar density fades at a galaxy's edge. The standard model, built on how protoplanetary disks form, predicted Kuiper belt objects should decrease smoothly and slowly, tapering off past 50 astronomical units. Instead, surveys led by Chadwick Trujillo and Michael Brown, published in a 2001 paper in the Astronomical Journal, found the population doesn't taper. It falls off a cliff. Object density drops by a factor of roughly 10 to 100, right around 50 astronomical units, over a span of just a few AU, a boundary sharp enough that almost nothing has ever been confirmed beyond it. Astronomers proposed the survey was simply too shallow to see fainter, more distant objects hiding past the apparent edge. Partially failed, deeper, more sensitive surveys conducted since 2003 keep hitting the same wall at the same distance. They proposed a passing star strip the outer disk clean early in solar system history, dragging the missing mass away with it. Unconfirmed, no candidate star with the right trajectory has ever been identified in the historical record. They proposed an unseen planet mass body gravitationally sweeping the region clear, shepherding material inward, or ejecting it outright, the same suspect blamed for entry number 5 on this list. Still unconfirmed after 2.5 decades of dedicated searching, they proposed the belt simply never had much material past 50 AU to begin with, undermined by formation models, which predict steady density all the way out, not a sudden wall. Something drew a hard line around our solar system 50 astronomical units from the sun, and whatever did it either remove the material entirely or is still hiding among what's left. Unseen, was the edge of our solar system built or torn? Nobody agrees on which. Number 7. The unstable Centaurs. In the early 1990s, astronomers cataloging minor planets were simply trying to fill gaps between Jupiter and Neptune, expecting to find a handful of stray asteroids in stable, predictable orbits like everything else that far out. Standard orbital mechanics says objects that far from the Sun, beyond the reach of strong planetary perturbation, should hold steady orbits for the age of the solar system. Instead, researchers found the opposite. Every single known Centaur, icy bodies crossing giant planet orbits, is on a chaotic path, gravitationally unstable on timescales of just 1 to 10 million years, a blink of an eye against a 4.5 billion year old solar system. A 1997 paper by Julio Fernandez, Tabari Gallardo, and Adrian Brunini in the journal Icarus modeled the population and found roughly half of all known centaurs are dynamically unstable enough to become Earth-crossing objects within a few 100,000 years. Astronomers proposed the instability was a modeling artifact, an error compounding over long simulation runs. Failed, repeated, independent simulations by different teams using different numerical methods keep confirming the same chaos. They proposed most centaurs simply get ejected from the solar system entirely before ever reaching the inner planets. Partially true, but a meaningful fraction don't. Orbital resonances with Jupiter and Saturn can just as easily kick a centaur inward as fling it outward. And the simulations can't say in advance which fate any single object gets. They proposed better long baseline tracking would eventually resolve the uncertainty. Failed so far, chaos theory means even perfect current measurements can't be extrapolated reliably past a few million years. There is currently no way to predict, decades in advance, which centaur gets thrown out to interstellar space and which one gets thrown at us instead. One of the bodies currently orbiting between Saturn and Uranus, cataloged and watched tonight by observatories around the world, is on a clock nobody can read. Which one, and when does its number come up? Number 6. Phaethon's blue tail. In 2009, a team monitoring the Stereo spacecraft's heliospheric imagers wasn't hunting for asteroid activity at all. They were watching for solar wind structures streaming past Earth. Standard asteroid physics says a bare rock with no ice shouldn't brighten or grow a tail near the sun. That behavior belongs to comets, not the asteroid 3200 Phaethon, source of the annual Geminid meteor shower. Instead, the team caught Phaethon doing exactly that, brightening and sprouting a tail at every close solar pass, for 18 recorded approaches between 1997 and 2022. Caltech researcher Qiqiang Zhang and colleagues published the resolution in 2023 in the Planetary Science Journal. Using color-filtered imaging from the SOHO spacecraft, they found the tail contains no dust whatsoever. It's glowing sodium gas vented straight from the rock. Scientists proposed dust ejection caused by thermal fracturing under the sun's intense heat. The original explanation dating back to Phaethon's 2009 discovery failed under direct filtered imaging. The dust-sensitive channel showed absolutely nothing in 18 separate observed apparitions. They proposed the sodium alone couldn't produce a tail bright enough to see from Earth. Failed the fluorescence physics, once modeled properly. Checks out precisely against every recorded brightening event. They proposed the source event was a single ancient disruption, a piece of Phaethon breaking off under rotational stress thousands of years ago, which would explain the billion tons of debris in the Geminid stream, but not a renewable source of sodium today. Still unresolved. What nobody has explained is where a supposedly dry, airless asteroid keeps finding fresh sodium to vent, apparition after apparition, orbit after orbit, without ever visibly running dry. Every December when the Geminids streak over your head, they are debris from a rock that keeps producing exactly what it should not have left to give. The source of that sodium has never been located. Number 5. Planet 9's gravitational shadow. In 2014, Chad Trujillo and Scott Shepard were tracking a newly found extreme trans-Neptunian object, 2012 VP1113, simply trying to extend the census of the outer solar system by one more data point. Standard solar system formation predicts distant object orbits should point in random directions, scattered by billions of years of gentle perturbation. Instead, when Trujillo and Shepard compared VP133 to the handful of other known extreme objects, every orbit clustered together, same general direction, same tilt, an alignment that should not exist by chance. Konstantin Bakian and Mike Brown at Caltech formalized the result in a January 2016 paper in the Astronomical Journal. Calculating the odds of this clustering happening randomly at under 0.007%, and proposing a single unseen planet, roughly 5 to 10 Earth masses, as the cause. Astronomers proposed observational bias, that survey teams only looked at one patch of sky, during one part of the year, at one time of night, manufacturing a false clustering. Partially damaging per University of Michigan researcher Kevin Napier's 2021 reanalysis, which the Planetary Science Journal later accepted for publication. But Bettigen and Brown's follow-up work through 2024, examining a separate population of low-inclination, Neptune-crossing objects, argues the clustering survives even correcting for where and when astronomers happen to be looking. They proposed a primordial black hole instead of a planet, small enough and dense enough to explain the gravity without ever being photographed. Unconfirmed either way, no gamma-ray signature consistent with a black hole has been found in that region. They proposed the whole effect could vanish once enough new objects were cataloged. Hasn't happened yet, new discoveries keep falling into the same clustered pattern. A decade of dedicated searching, now including the Vera C. Rubin Observatory's ongoing full-sky survey, has found nothing solid enough to end the argument either way. Something with planetary mass may be quietly rearranging the outer solar system's furniture, and we have never once seen it directly. Number 4. The uncatalogued city killers. In the 1990s, NASA's Space Guard program was assigned a narrow, practical task: find and track every near-Earth asteroid larger than 1 kilometer, the size capable of ending civilization outright. The standard assumption was that once the big ones were mapped, the remaining risk would be manageable. Instead, as the survey matured, attention shifted to a smaller, far more numerous population, asteroids in the 140-meter range, large enough to level a metropolitan area on impact. NASA's own 2024 estimates, drawn from Center for Near-Earth Object Studies, tracking data, put the total population of these city killer-class objects at roughly 25,000, of which an estimated 40% remain completely uncatalogued. Astronomers proposed ground-based surveys would eventually close the gap, given enough telescope time and enough years of steady cataloging. Failed to keep pace, the discovery rate has never caught up to the estimated total population, and the gap has barely narrowed in over a decade. They proposed most real-world risk comes from well-tracked objects with known, stable orbits, leaving the uncatalogued ones as a statistical footnote. Undermined badly by events like 2013's Chelyabinsk impactor, a 19-meter object nobody saw coming, arriving from the sun's glare with zero warning, exploding over Russia with the force of roughly 30 Hiroshima bombs and injuring over 1,000 people. They proposed space-based infrared telescopes would finally solve the detection problem once launched. Still pending, dedicated missions remain years from full operational capacity. 10,000 of these city killers are calculated to be out there right now, on orbits nobody has plotted, crossing Earth's path on a schedule nobody can predict. Somewhere in that dark, uncounted 40%, one is already inbound. We just don't know which decade it arrives in. Number 3. The dark comets. In 2016, astronomers using NASA's NEOWISE data were doing routine orbit fitting on a small near-Earth object called 523599, catalogued years earlier as an unremarkable asteroid. Standard orbital mechanics says an object with no visible tail, no coma, no dust, a bare asteroid, should follow a purely gravitational path, predictable from Newton alone. Instead, Darrell Seligman and colleagues found 523599's trajectory was being pushed off course by a real, measurable non-gravitational force, at 60 times the level statistical error could explain, with nothing visibly venting from its surface to cause it. Seligman's team published the naming paper in 2023 and a follow-up in the Proceedings of the National Academy of Sciences on December 9, 2024, brought the confirmed count to 14 objects, splitting them into two distinct populations by orbit and size. Scientists proposed instrument error, imprecise tracking compounding into a false signal over time. Failed, the acceleration is real, statistically overwhelming, and repeatable across independent tracking data collected by multiple observatories. They proposed the Yarkovsky effect, a slow thermal push from sunlight absorbed and re-radiated unevenly off a rotating surface. Failed, the magnitude and direction of the force don't match what Yarkovsky physics predicts for objects this size. They proposed radiation pressure alone, sunlight physically pushing the object off course, failed for the same reason, too weak, and pointed the wrong way. The leading explanation now is invisible outgassing. Ice sublimating in quantities far too small to produce any visible coma, but still strong enough to steer a rock, verified independently by a 2024 Icarus paper modeling seasonal heating across rotating nuclei. Some estimates suggest up to 60% of all near-Earth objects could belong to this class, meaning most of what shares our neighborhood may be silently changing its own course. And we have no way to see it happening until the orbit no longer matches the prediction. Number 2. 2020 SO. The debris that came home. In September of 2020, the Pan-STARRS survey team flagged a newly detected object on an orbit that looked disturbingly Earth-like, low velocity, nearly circular, the kind of signature that usually means something. Standard practice says any small body discovered on an Earth-similar orbit gets checked immediately against known asteroid catalogs before anyone gets excited. Instead, when Paul Chodas at NASA's Center for Near-Earth Object Studies ran the numbers backward, the object's path matched no known asteroid family at all. It matched the launch trajectory of a 1966 Centaur rocket booster, part of NASA's Surveyor 2 moon mission. Chodas confirmed the identification in December 2020, tracing the object's spectral signature to steel and paint consistent with 1960s-era rocket construction, 54 years after it was lost. Astronomers proposed it might be a natural asteroid with a merely coincidental orbit, low velocity by pure statistical chance. Failed under spectral analysis, run by scientists at the University of Arizona, the light signature matches steel and white paint, not silicate rock of any known asteroid class. They proposed existing tracking networks would have caught an object this size sooner, given decades of dedicated SpaceGuard operations. Failed completely, it had drifted in and out of Earth's gravitational grip repeatedly for over half a century, unnoticed, undetected, entirely uncatalogued the whole time, occasionally captured briefly as what looked like a temporary mini-moon before slipping away again. They proposed the booster should have been tracked continuously since its 1966 launch. Failed, NASA's own early tracking simply lost it, and nobody thought to look again for 54 years. A piece of Cold War-era human hardware orbited undetected near Earth for decades before anyone noticed it had come home. If a school bus-sized rocket booster can vanish from tracking for half a century, what else launched from this planet is still out there, uncounted? Number 1. 3I/Atlas. On July 1st, 2025, the Atlas Survey Telescope in Rio Hurtado, Chile, was running its routine nightly sweep for near-Earth asteroids when it flagged a fast-moving point of light. Standard orbital mechanics says any object bound to our sun follows an elliptical path, you only get a hyperbolic trajectory, one that never returns, from something that was never gravitationally captured in the first place. Astronomers confirmed within days that this object, 3I Atlas, was moving on the most extreme hyperbolic path ever recorded in the solar system, arriving from interstellar space at nearly 58 kilometers per second. A team led by Adam McNeil and Darryl Seligman, publishing follow-up kinematic analysis through 2025, traced the object's pre-encounter motion to the galaxy's thick disk, calculating a likely age between 3 and 11 billion years, meaning this object began drifting through the Milky Way before our own sun had finished forming. Scientists proposed it might be debris kicked loose from a nearby star system relatively recently, in galactic terms. Failed, the trajectory analysis shows it statistically unlikely to have approached any star as closely as it just approached our own sun at any point since its ejection. They proposed it might be artificial, a technosignature rather than a natural object, a hypothesis serious enough that the Breakthrough Listen initiative dedicated observing time to it. They checked for artificial radio emission using the Allen Telescope Array within days of discovery, and again with the 100-meter Green Bank telescope at closest approach in December 2025, sensitive enough to detect a transmitter as weak as 1/10 of a watt. Nothing detected, ruling out one explanation but confirming nothing about what the object actually is. What it does carry is a deuterium to hydrogen ratio over 30 times higher than any comet ever measured in our own solar system, chemistry assembled around a star system that likely died before our own sun had even finished forming. It already made its closest pass to both the sun and the Earth, and it is now leaving, permanently, carrying whatever it is back into the dark it came from. Never to return. We had one look. We will not get another. 12 possible visitors. 10 confirmed anomalies. Every entry on this list orbits within reach of a telescope you could point from your own backyard, and every one of them still breaks a rule we thought was settled. The universe is not confused about what shares this solar system with us. We are. The rocks are already out there, on paths already fixed, doing whatever it is they do, whether or not anyone is watching. If you want to see more videos like this, click the video on screen now.